Hello again. We have finished our lab 1 where we have studied our 4-bar linkages. That leads us to lab 2 where we're going to use working model 2D software to analyze mechanisms. So our lab 2 has two parts. On the first part, we're going to learn some basic steps using the working model 2D towards making a mechanism. Then we're going to practice two mechanisms to how to analyze that will develop the skills needed to use working model software. On the part 2, you'll be assigned a mechanism that you have to design, create, and perform the analysis. So what is the learning objective for part 1? Analyze a 4-bar mechanism using the working model software. First, we're going to start with why we're using the software for mechanism analysis. Then we have to build a kinematic model of a 4-bar mechanism. We will animate the motion of the mechanism and will determine the kinematic values of the mechanism, how maybe a point on the body is moving, what is the velocity, what is the position in x and y coordinate of that point, this kind of analysis. So let's see. A brief discussion on why we use software for mechanism analysis. You already may have known SolidWorks for CAD design, or AutoCAD or Inventor. So similarly, this software will help us to create and simulate a machine prototype, so that we can, before we make the original physical prototype, we can detect the flaws. And since we're using a computer, it'll save some cost before you invest and make it physically. And it also helps us rapid product development, because you can develop anything once you have the idea and the dimensions in a PC. And finally, the um, main advantage, one of the main advantage is that you can solve kinematic and dynamic equations to determine the motion and forces of any part of the mechanism. So the software and basic tutorial for using working model 2D can be found in this website. I have also uploaded the basic tutorial on your Blackboard. Along with, you can also see the laboratory handout on the Blackboard. It outlines the way to design the mechanism that you're gonna see in from the following slides. So that leads us to our first model. You can see on the right, this is the final 4-bar mechanism looks like. So our first model um, is a 4-bar mechanism. Our goal is to use the working model 2D to model the 4-bar mechanism. In the following slides, I will show you the basic steps towards how to use the software and how to build the 4-bar mechanism and to resize, run analysis, how to connect points, how to focus on a point and trace the path of the point of interest, measure the position of a point, such things. So let's begin. at this point, after adding a motor, when we're expecting for a 4-bar mechanism is a crank rocker, so the input link should supposed to rotate 360-degree. And if you remember your first lab when we learned and applied Grasshopp's law, we can also apply this on this link, the Grasshopp's law, to check whether it will be fully functional or a lock mechanism. So for this, we can find the coordinate. If you take your pointer at these 2 points, you can see the coordinate of these 2 points, and using this equation, you can find the length of the frame. As you already know, that frame is fixed, so we don't need a visible link here. So the frame length is found there, and that leads us to our minimum and maximum length link. And we can apply Grasshopp's law for crank rocker. So shortest and longest length would be less than the other two. And if you know the distance of this point to that point, this point to that point, and all the length are summed up, you will see that the shortest and longest will be less than the other two. So the Grasshopp's law is verified, and when you run the motor, you will see that it is continuous. It is having a continuous 360-degree rotation without having any lock. measuring a point position on the middle bar, let's do two more practices. So let's change the mass of the horizontal bar from the properties box and rerun the simulation and compare your result from the previous one when the mass was different. So does changing the mass of the link change the point position on the movement? So follow this task and save the data and analyze them and present them in your lab report. So we have finished our first model and analysis using the working model 2D software. Now we're gonna do another mechanism practice. In this case, we're gonna model a slider crank mechanism. It'll be similar but a little bit different than the first model that we just developed. So the image on the right, this is how the slider crank mechanism will look like. You have to make a similar one. It includes similar steps as the model 1. We will have to create the links, connect the links, add the motor, and apply and run the analysis. You will also have the handout where these steps are written in words, but I think by this time you already have experience how to deal with the software, so try yourself first, and if you get stuck you can look at the handout if needed. So let's do model 2. So once you have finished both model, the next question is what will be in our result. So for both models, model 1 and 2, submit the figures of your model that you have created and explain the step by step for model 1 and 2 in your own word. So for both model, present the position data of a point of interest. This will be different for each person. Each of you will select a point of interest on the horizontal bar, or it could be on the vertical link of your own interest. So it will be different from person to person, and trace the path of that point. Plot the position of the point of interest when you collect the data, and then from the data, from the Excel sheet, plot the X, Y, and angle with respect to time. So once you have the data collected and result prepared, that leads us to a discussion session. What will be our discussion point? So minimum, compare the plots created in the results section with the plot generated in the working model. So what we're asking here, that once you have collected the data out of the working model software, generate your own plot in Excel sheet and compare with the graph plot that the working model 2D shows you, and see if there is any discrepancies or dissimilarities between those, and if there's any why. Next, discuss and verify the Grashopp's law for the models. Remember, we talked about also in lab 1 how to apply Grashopp's law. So apply Grashopp's law for both models and just verify why it was continuous or why not was not continuous, and does it follow the Grashopp's law. And finally, comment on your experience of analyzing a mechanism learned from these two models, and there will be one that you'll do by yourself next. So those together, three model practice. So we have finished our part one, where we have practiced some basic steps and practiced on two models, analyzed, data collected, plot created, and submit the report. So that leads us to our part two, where you're going to be given a real life model to create the mechanism and perform analysis. So the objective of part two is analyze a landing gear mechanism using working model software, where you have to create the real life mechanism that you can see on the right image. I have a bigger image on the next slide. Then again, similarly for similar to the first two model, you have to collect the data from the software and analyze functionality of this mechanism as an engineer. So the dimensions of the real life mechanism is given on the image on the right. So we have to generate a model of this linkage. The motor on the crank operates at 20 RPM. You have to determine the resulting angular displacement on the wheel. Then you have to analyze the parameters that are necessary for using this landing mechanism. You have to find those and do the analyze the parameters, and you have to include the input data, results, and all the needed schematic figures and plots in your lab report. You should create result section and discussion section as we have discussed for model 1 and 2. So on the conclusion part, it is same for all the labs, and for the first part or second part, you have to create summarize briefly the experiment, the main result, and inference that you draw from the lab. These are the list of the reference that we have used, the working model tutorial, basic tutorial from their website. We also use the textbook that we're using, and the model 1 and 2 are given in written form, the step-by-step in the laboratory handout. So that concludes our lab 2. Next lab is our lab 3, where we're gonna build a robotic mechanism with Lego Mindstorm EV3 kit that will be able to draw a circle. So you'll be required to design a mechanism using the Lego Mindstorm that will draw a circle. So I'll see you on the next lab.